And welcome to another episode. So again, I'm running 2 days behind, but uh, because of work, but that's fine. Let's continue with the next problem. So it's LRU cache. So you need to design LRU cache so that it supports get and put functions. So get basically gets the value of the key if it exists in the cache, otherwise returns -1, and then put inserts it in the key if it's not already present. If it's present, then it should when the cache is reached its capacity. Okay, so if set or insert is not present, right? So if it's not present and if the capacity is reached, it should invalidate the reached recently used item before inserting a new item. The cache is initialized with the positive capacity. Can you do both operation O of 1? Okay, so let's look into our approach. So what is happening is, in our example here, let's say initially I initialize the cache with capacity 2. So I'll have a cache of capacity 2, two cells here, right? Now I get 1 comma 1, so I insert 1 comma 1 here. So 1 is my key and then 1 is my uh, value. Then I put 2 comma 2. So 2 comma 2 is the is inserted here. So what I'm trying to do here is, like, the one at the back means it was used in the past, and this is the latest value that we have used because it's just now we have got a put. Now we get to do a get. Obviously it's present in the cache, so what we do is, because now it's recently used, I would go ahead and update my cache like this, right? And then I'll do, so now my latest update value is 1, and the least recently used value is 2. Now next time I get put 3 comma 3. So because the cache is already filled, because initially we saw the cache at capacity of 2, so what we are going to do here is, we'll remove this old value and insert the new value. So the new cache will be something like this, right? Because this is the recent value and this is the past one. Now I get of 2, it's not there, so I print -1. Then I do a put 4 comma 4, so I'm gonna remove 1 comma 1, so my cache becomes 4 comma 4, 3 comma 3. Then I do a get of 1. 1 was just previously removed, so we get a -1. Then we do a get of 3. Yes, 3 is there, we return 3. So now the new cache becomes like this, 3 comma 3, because 3 was touched in the cache, so we update the cache. So 3 comma 3, and when we do a get of 4, 4 is there, so we return 4, and then the new cache would be 4 comma 4, 3 comma 3, right? So now we need to do all the operations is O of 1. Let's see how we can do that. So one major thing that we saw is there are two conditions for put. Let's focus on get first. I think for get it should be straightforward, like if I keep a hash map with the key value, so then if that value exists in the hash map, I return the value, right? So get is done. Now what about put? So for put, what we can do is, let's say there are two conditions, right? One is if if capacity reached, right? So if capacity is reached, what we are doing is, if the new value, so okay, so there are two conditions here. One is cache has space, right? So if cache has the space, we simply add it to the front of the list, right? And if it doesn't have the capacity, what we do is we remove the last element and insert it in the front, right? So let's say in case of where there was 1 comma 1, 2 comma 2, when 3 came in, what we did was we removed 2, so this end part was gone, and we inserted in the front. So 3 comma 3 was reached. Similarly, when 4 comma 4 was reached, we deleted this part and inserted 4 comma 4, right? So this is one condition, and the another condition is if the capacity is not reached, we don't remove anything from the behind, we just add it to the front. So adding to the front, the new element is same. It's just that removing from the back happens if when the capacity is reached, right? If it isn't, then we don't touch it, right? Now what we can do is we can jump into the code and try to implement it. I'm gonna use map obviously for this part, and for this list I will use a data structure called list in C. So this could be my queue. I'm giving it a name queue, and then what I do is ordered map. So int is the key, then I am storing value, and also I'm storing the iterator to the list, because if we store the iterator, then it's easy to delete I can name it cache, so delete the value from the list in O of 1. So and then I give a capacity cap, so cap equals to capacity, that's it, then it's initialized. Now for get, I check if cache dot find key is not equal to cache. So if I find the key in the cache already, so I need to move it to the front, right? I don't do anything else. So in order to move it to the front, I delete old position in the list. So to delete that, what I'll do is I'll do an auto it equal to cache of key dot second to get iterator. Then I do q dot erase t, right? And then once I've deleted that, I add it to the front. So q dot in list, we use this method to add it. So I add the key to the front, and then I update my key in cache dot first. I'll update the value stays the same, yeah, I update the iterator. So q dot pt. So because now it's in the front, I will use that, and I need to return, so return cache of key dot first, because if you see, we have a pair like a tuple. So first value is where I'm storing the value, and the second value is where I use the iterator. If none of these happens, then I return minus 1. So get is clear. For put, I check again if it's in the cache, right? If it's in the cache, what we do is we just move it to the front, and we update the value here, because we are updating the key, because key is already there, we just need a new value to be updated. So I delete old position in the list, can do same here, correct, and then I add it to the front. Now I update the value of key dot first to be the value. Okay. Else, now in else two cases can happen. If my cache size is greater than equal to capacity, right? So in that case we need to delete. So in this case we delete the last item. So we do that by, I guess, list c++ get back. Front and list, yeah, front back it gives me back. If we list q dot now, q dot back will give me the value, right? Id last key. So using that last key, I need to remove it from the map, and I need to remove it from the back as well. So q dot erase remove, sorry, cache of last key at second, and then I remove it from the cache as well. So last key. Right, once I have deleted the last element, I add the new value to the front. Right, so it's like I'm just copy pasting this, so it will be adding it to the front, which is with the value q, and then cache of key. Now this will be a new value, so let's go there, value comma q dot begin. Let's run this and see, test this if it works on the test case. Awesome, it works on the test case. Let's clean up the code. We see that this is where it's like the same from, right? So we can have it move to front value. And then you can call this method to front on key, comma, value could be or is just the key. Yeah, I can push the key, and I can call this here at the key as well. Front key. Let's run this now. See, it should work. Awesome. Let's submit it. Awesome. So I guess it was pretty clear. I'll add comments to this code, like if key is found, move it to the front. If key is not found, then enter else code. If capacity of cache is reached, we delete the last item, we delete from list, we delete from map. Right, hope this was interesting and understandable. If so, please subscribe to my channel and give me a thumbs up. Thanks everyone.